I have this module from DFRobot. It's a voice recognition module, and I want to use that for my Magic Mirror project. So I will be connecting it using I2C, and then hopefully I will be able to give voice commands to control my Magic Mirror. So welcome and hope you enjoy. This is a new device from DFRobot that I'm waiting for. It's a voice recognition module. So it contains a complete voice recognition hardware software, including 2 microphones. And there's also supposed to be a speaker somewhere. I guess it's in this one. You can connect an external speaker. But I will first try with the built-in one. Here you can see the microphones. You have an I2C connector. You can use a UART as well, but I will use the I2C connection. It actually says speaker 2. That's connection for the speaker here. Or you select there. That's a switch. So you can select if you want a built-in speaker or an external speaker. You can select it here, and here you can select the I2C or UART mode. So we will use I2C and speaker 1 to start with. Looks nice. I like the quality of DFRobot. All the different things, sensors and so on that I have purchased from them. Been really good quality, quite easy to use, limited documentation, but it's good enough. Not everything is documented, but you can certainly get started in an easy way. So far, it also comes with some connectors here. So if you don't have that, there's a cable for the interface as well, and prepared for some testing as well, so really easy to use that. So let's have a look on the facts of the module. You can find a product wiki on DFRobot's homepage, and it's quite extensive. And the only thing I'm really missing here is that there is no explanation about the different commands you can give through the APIs. That would be nice to have, so you understand a bit more on all the different options. There are not so many, so not a big thing, but otherwise it's excellent. So if we start with having a look at the features here, we can see that it supports I2C and UART, good. 5 and 3 volt, that's also good. It has 121 commonly used fixed commands built in. We will have a look at that. Built-in speaker, which is good because it's very easy to get started. And still you can connect an external speaker if you want better quality. It also has 2 microphones, which is good to help with the distance of recognition. I haven't tested that yet, so I will be doing that.
The power consumption is rather high, and that's expected, I would say. So you can't really connect it to anything but the main power. That's something to consider. It has one wake-up word, which is programmable, which is very good. And it has 17 custom commands that you can program yourself. That seems to be enough for me, at least in my applications. And the board is small and very well made, so that's also positive. So if we have a look at the command words then, the way this works is that whenever a command is recognized in a module, you will get, or you will read the ID of the command. So you will get back the ID here. So if any of your custom commands comes back, you will receive 5, 6, 7, or whatever ID is connected to the command. And here is a bit tricky because the way the IDs are assigned is that the first command you'll learn will be number 5, and then the second 6, and so on. So it's kind of hard to change the IDs, but never mind, it doesn't really matter. And here also you can see the fixed command words, and they are really all over the place. It's go forward, stop oscillating, stop playing, but maybe it can be useful for some. I don't see too much here that I will be using. To keep in mind is also that each command has a pre-programmed response. And you can't control that, but the response is there. You can mute it if you want. But you can also reuse the response. So at any given time, you can have it send out the response for ID 22, for example. The responses are not here, so you have to find out yourself, and you can't reprogram them. And that's, to be honest, the thing that I'm missing in this module. And that is the ability to program your own responses. Or in best case scenarios, you would like to have a text-to-speech functionality. So you could program it and get it in the same voice. And you could program any response. So maybe for the future that would be nice to have. But currently you're stuck with pre-programmed responses. But the positive thing is that you can at least reuse them if you want. So I've connected the voice recognition module to the Raspberry on I2C. So I'm just mounting the Raspberry back into the Magic Mirror now. Now we'll see if we can get it to run.
So now it's time to prepare the module, and you do that by voice commands. So we program it with voice commands, and I want to set the wake word, and I want to set the command words that I will use. If you later change your mind, you can just ask it to delete the information, and you can start from the beginning again. So let's do that. Hello robot.
How can I help?
Learning wake word.
Learning now. Be quiet. Please say the wake word to be learned.
Hello magic.
Learning successful. Please say it again.
Hello magic.
Learning successful. Please say it again.
Hello magic.
Okay. Learning completed.
Learning command word.
Learning now. Be quiet. Please learn the command word according to the prompt. Please say the first command to be learned.
Show energy.
Learning successful. Please say it again.
Show energy.
Learning successful. Please say it again.
Show energy.
Okay. Learn the first command successfully. Please say the second command to be learned.
Hide energy.
Learning successful. Please say it again.
Hide energy.
Learning successful. Please say it again.
Hide energy.
Okay. Learn the second command successfully. Please say the third command to be learned.
Turn on sauna.
Learning successful. Please say it again.
Turn on sauna.
Learning successful. Please say it again.
Turn on sauna.
Okay. Learn the third command successfully. Please say the fourth command to be learned.
Turn off sauna.
Learning successful. Please say it again.
Turn off sauna.
Learning successful. Please say it again.
Turn off sauna.
Okay. Learn the fourth command successfully. Please say the fifth command to be learned.
Exit learning.
Okay. The learning mode is exited.
So before we can use the module on the Raspberry Pi, we need to do a couple of things. First, we need to enable the I2C in your Raspberry. So run the config command, go to interface options, I2C, and make sure it's enabled. In my case, it's already enabled. The next thing you want to do is to make sure that you have SM bus installed for the Python I2C support. Not sure if it's normal to have it installed, but otherwise you can install it with sudo and SM bus, and it will install the library for you. And the third thing we need is that we need to get the code from DFRobot. And here you need to take care that you get your code into your software directory on your Raspberry. I had some issues with that first, and I ended up moving the Python file directly into my main directory, and then it worked. So now we're prepared for starting to use the I2C. So the next thing we need to do is to add this to our Python code. And first of all, we need to import the library at the top here. And this is why you need to take care of putting it in the correct catalog so Python can find it. I also added SM bus for the I2C. And then you're ready to initiate the class, and you can do that like this. When you download the code, if you go to that directory on your Raspberry, you will find an example as well, both for I2C and for UART. So those are very simple examples, and you can just use the code straight off. And in my case, I just copied the initiation here. And if you get problems here, it's probably due to maybe you have not enabled I2C or you have connection issues or something. And also check your directory for the library. And then we're ready to use it. And that's really not so much to it. In my case, I put this command into my function that is looking for motion. I have a motion sensor that triggers and is checked every second. And if there are motion, it will turn on the display on the Magic Mirror. So that seemed to be a good place to check for the commands, if there have been any commands to the voice recognition module. And the way you do that is that you simply get the command ID. And then you can build up your own functionality here. And, it's only the imagination that stops you here, what commands you want to have and what that should trigger in your application. So I will show you later an example of what I did with this. But this is where you get the information back from the module. And that's really all it takes. You can also adjust things like the volume, and you can mute the speaker at certain times if you want that. And you can also set the time for how long it should wait for additional questions. So the wake up word wakes up the module, and then if you're silent, it will stay on for 15 seconds maybe and then go back to sleep. And this is also something you can control. So let's get this up and running. So one way that I will be using the voice recognition is to select different pages. So normally whenever the main page is updated, which is the refresh rate is set to 5 seconds, I will return this information down here. So it's returned from the Flask web server, and it's returning the HTML file for my main menu. So what I did was that I added the possibility to change the menu page, basically. And at this point, I just have one other. So if I give the voice command to show energy, it will set the menu page variable to 1. And if that happens, the next time the browser is refreshed, which is 5 seconds approximately, I will return this page instead. So in this way, I can change to different pages, and I can have, of course, as many as I want, toggling between the pages. So it's a simple way, but of course you can control any parameters of the code you want. I also added a timeout here, so if I don't give the command to hide energy again, it will return to the main page within 60 seconds here. So one way to use it, and I will show you how this works.
Yes, it's hard to see with all the glare, but that's a bit better. So let's see what happens if it will respond. Hello, Magic.
Yes, I'm here.
Show energy.
Okay, got it.
The refresh rate of the web page is set to 5 seconds, I think. Oh, there you go. Nice.
I'm off now.
Hello, Magic.
Yes, I'm here.
Hide energy.
Done.
Ah, works. I'm happy.
So full disclosure, I've been running the voice recognition module for a few days now, testing it, and so far so good. It works like I want to, but there is some kind of problem. And I don't think it's the Raspberry causing the problems, but it's the module itself. After a few days, it seems to hang. So even if I'm able to give the voice commands, I get a reply from the module, but nothing happens on the I2C. And I can also see that my Raspberry fails in the communication, in the I2C communication after a few days. So I get a failure there. So I will be continue testing here a bit to understand what's going on. It usually helps if I just restart the module actually. I just pull the power and put it back on, and then it works. Restarting the Raspberry itself doesn't help. So I think it's in the module. Something is hanging in the I2C communication, and power off helps to clear it out. So I will be testing a few things, and I will certainly get back to you and explain what I'm doing and how I can manage it. As I see it, worst case scenarios, I will simply add a function to reboot it if I lose communication. But that's just nothing you want to do.